Hello folks. In this video, we're going to take a look at building a Hangman game with Python. So let's start off. We'll add a little comment here. Hangman game. We'll give a little instruction about what's happening. Computer picks a word from a list. And then player makes a guess one letter at a time. Okay. And for this Hangman game, what we're going to do is use the skills you have to use dictionaries, use arrays, lists, right? All the stuff we've been practicing. And the final product will look something like this, where we'll have a simple ASCII looking hangman's post, noose. I don't know exactly what it's called. Gallows, I guess. In case we see the outline of the head and then the body, and then this person's being hanged because so far we're guessing, but we're not there yet. We have to guess the final letter in this word. So we're going to work it out so that it prints off all this stuff to the screen for the user, and we can say they guessed or they didn't guess right, and we can add on to the little ASCII guy as we go. Okay. For the imports, we'll have to import random to get a random selection. We'll set up some constants. Constants are variables that don't change throughout the program. So the art we're going to use for the ASCII art for the Hangman character, we won't be changing that. So that'll be a constant. I will post a link to the ASCII art that's already built for you, so you don't have to type all this out. But basically, it's going to look like this, where we set up a Hangman. It's all capital letters. That's kind of convention in Python to write out capital letters to define a variable that's not going to change. And here we have a list. So this is just a list of just drawn out bars, plus signs, minuses to create our different states that our Hangman character could be in. Next, we'll set up our list of words. And here you can enter whatever words you want. We'll do all caps for this one. I'll do pizza, snake, Washington, and moon. So you can pick whatever words you want. We'll do all caps because we'll be getting some user input, and it's just going to be easier to deal with the user input once we have everything in all caps. We could just convert the user input to all caps and do a comparison against it. Let's take let's set up a max wrong variable, and this one is going to be the length of the Hangman -1. If we look at the number of characters here, we have, or number of states we have 1, 2, 3, 4, 5, 6, 7. So max wrong, the length of the Hangman should be 7, but then we -1 because the length includes the empty gallows that the player gets by default at the start. So we don't want to penalize the player for having that there already. So the number of max wrong guesses, well, actually, we would, if we just did the length of the Hangman, we'd actually give them an extra guess, but we're not going to allow that. Okay, so we have our list, our length of, or the maximum number of times they can guess wrong. Let's initialize variables. Let's get our variables that are going to be changing there. Let's do pick a word, and we'll just set up a variable called word. And this one's kind of neat because we can do random, and instead of the usual range that you'd probably use to select from a range of numbers, if you had like 20, you could finagle this to pick off of this if you were using like a different language that didn't have a lot of methods here. But we have a method in Python that we can use, random.choice. And instead of having to come up with some fancy wording for how it can go through and pick off the list, we can just say random choice, and then we give it the words, and a word will pick a random choice off of it. So we can do print word, and we can see what happens. Snake, every time we run it, it should be, yep, there we go. It picks bear, picks Washington, moon. So every time we run it, it's going to pick a different word, which is pretty cool. Okay, next up, let's do dashes for each letter in a word. For that, let's set up current guess equals, and we'll put a dash there, like a minus sign, times the length of the chosen word. So this is going to give us, if we print it out, current guess. It's going to give us for any word that it picked. Actually, I'll do print word as well too. Okay, so for pizza, what it's going to do is it's going to substitute out each character. It's going to go through and say current guess, because we printed out current guess equals minus sign times the length of the word. So times how many characters you have. So if you have 5 characters, it's going to give you 5 dashes, right? Okay, so we can get rid of that. Those print statements, and let's keep going. And we can do, let's wrong guess counter. And we can set up something that says wrong guesses. We can set up to be 0. Next up, let's keep track of used letters tracker. And we can just set up used letters. And we'll set up an empty list there. We'll toss them in there once we get going on this. Okay, let's set up the main loop. Okay, main loop, meaning that anytime you have a game that you're trying to build, it's always going to have a main loop. And game engines have this built in. A lot of things have this built in. We actually have to print. We have to actually make our main loop here. Hangman. Let's print off a little welcome statement. Let's do print. Try to guess the word, so we can let the players know what they have to do in case they've never played Hangman before. And here's our main loop. While wrong guesses is less than max wrong and current guess is not word. Okay, so we have a compound statement here, and what this is going to say is basically, while the wrong guess is less than the max wrong, we're going to continue this loop. So as long as they have not run out of options, and current guess is not the word. And what this does, it allows the player to guess the correct word on the last chance. So, and it will exit this loop if they happen to guess the correct word at any point inside of this loop. So this loop's going to run over and over again, checking if something is true or not. Okay, so here's the main logic we're going to be doing here. So let's go through. Let's do print Hangman. So let's print out that Hangman, and we have a list of pictures here we can choose from. So which picture do we want to show? Well, we're going to show the current one, that is the current place, right? So these are all ordered. So starting from 0, 1, 2, 3, all the way down, all the way to 4. Well, we already have a tracker, right? We have a wrong guesses tracker. We already have a 0. So we can use the 0 here, wrong guesses, to show us. And so if we run it, we can see that the main loop's going to run. We have no way to stop this, but it's just going to continue printing off the same guess over and over again, which is the first one, 0, right? Because the current number of guesses is 0. Okay, and next up, let's do print. Let's tell the user you have used the following letters. And let's print off to them used letters. Let's also print off, so far the word is, and current guess. Okay. So we have the print statements all telling the user what's happening. Next up, let's have a new variable called guess, and this will be an input. And this one, we're going to do enter your letter guess. And we'll also have to convert that. Guess equals guess dot upper. That's going to convert that to uppercase. So we take any user guess, we basically going to allow them to type it in, and then we're going to convert that guess to an uppercase version of itself. And we do this because our original list words is going to be bare. This solves the problem. I mean, if a user is going to type into your program, if they're going to type into an input box, you should plan for the eventuality that they're going to break it. Meaning that if somebody eventually would type in something like bear or something like that, and you would do a check, does this equal, bear? And it's going to return false. It's going to return no. And even though the user knows it's bear, you're checking for the all uppercase bear, and these are not the same. And the user's going to get frustrated when they lose because they did type in bear, and why is the stupid program not working? So to solve for that, what we do is we take the user guess, this thing that they type in there, this mess, and we just convert it to bear with guess equals guess.upper. We take that same guess that we got in originally and just convert to an uppercase version of itself. So that when we do the check, right, we would do the check here. We do user guesses bear. Does that equal bear? That returns true. Player wins. Everyone's happy. And the user has not broken your code. So yeah, plan for users to always break your code. If there's a way to break it, they're going to try to break it. Not even on purpose, just because they're people. While guess in used letters. Okay. For this right here, we're going to set up another loop inside of our loop. Yes, we can do that. And so while the main program is going, we do want to set up another check. And as the person enters their letters, we want to check to see if that letter is already in the list of used letters. So let's do a little thing here. We'll comment, check if letter was already used. Okay. While the person's guess, while the letter guess is in the used letters, let's print off. You have already used, or say you guessed, already guessed that letter. And we'll tell them what letter it was, guess. And we'll do a new input, guess equals input, enter your letter, guess equals guess dot upper. So we got to do that same thing over again we did above, because basically while this person's while they keep on guessing the same letter, say they type in A, we want to keep on saying you already guessed that letter and give them another chance to do that. There's no way to go back in the line. So once you're on line 92, you can't go back to line 88 and 89. Maybe if you wrap this inside of a function, that would work. But for this point, we're not going to make it too complicated with the functions. We're just going to keep it in the main program. So in that case, we can solve for that just by asking the player again, the same question over again. Okay, so yeah, we check to see if if it's there. Okay, if say they don't add a letter they already added before, what we want to do is we want to do used letters, and we're going to do dot append and guess. So we're going to add that guessed letter to the list of used letters, as long as it's one they haven't guessed before. If it's one they've guessed before, they're going to be stuck in this check if it's already there. And I'll add a comment here. Use letters append, add a new guest to guessed letter to list of guessed letters. Okay. Let's keep going. So we only have a couple more lines left. And let's do, for this main loop, yeah, let's go on to the next one, which is going to be check guess. And let's check to see if their guess is right. Guess and word. So if the letter that they're guessing, their guess letter, if it's in the word that was chosen, okay, we can print you have guessed correctly. And for this one, what we can do is, this is going to take a little bit of logic here, but what we're going to do is basically combine the letter that they have guessed, right, and give back a new version of that list of dashes, but we want to have the letter included in it, right? So if they guess P for pizza, we want to make sure that the first letter is P and the rest of it is all dashes. So let's see, give a new version of the word with mixed letters and dashes. Okay. I don't know why that capitalized there. Dashes. Oh man. Get over there. Ashes. Dashes. There we go. All right. Okay. So, all right. So we have if, guess, and word, print correctly. Okay. So for this one, let's do new current guess. So they have a current guess. We're going to give a new current guess. Is going to equal just right now an empty string. So we'll just put a couple of quotes there. It will do another for loop. For letter in range. This is similar to for ed in range or I in range. We can just do for letter in range, length of the word. So for the length of the word, check every letter inside of that word. And if the person's letter they guessed is equal to the word letter, so it goes through the word, say it's pizza, for every letter in the length of pizza, okay, check is the guess that they made is, say, I, is that equal to the current letter in the word? So it's going to go through each letter and do a check. Okay, this is a for-in loop, and it's going to do a check to see if it's inside of that word, if that letter is there. If it is, okay, if that's true, this is an if statement. If true, let's give new current guess plus equal guess. So let's add that new current guess is going to get that letter. Okay. Else, let's do new current guess plus equals current guess letter. Okay. And what that basically does is it will go through and new current guess. Yes. All right. So this will go through and just replace the new current guess. It will fill it out with the current version that's already there. So basically fill it with a bunch of dashes. So if the guess equals a letter in the word, swap it out with the actual letter. If not, just give back to new letter guess those listed dashes. Okay. And we can actually do, for ed in range word, we can actually do print new current guess. Let's see if this will work out halfway through. I didn't put it on line 111. Let's see if I make this a little bigger. We can take a look at what's going on here. Let's see. New bad input on line 111. For letter in range, length of word, if guess equals word letter, new current guess plus equals guess, else new current guess plus equals current guess letters. Oh, right, yeah. There we go. All right, cool. So we start to see the actual program start to come together. Welcome. Try to guess the word. You have used the following letters. We see nothing here so far. The word is blank, all dashes. Try to enter your letter. Let's enter A. Okay, you have entered the letter A. Okay. And so far, the word is still a bunch of blanks. And so, let's see. We actually haven't got this person wrong yet. Let's see what else there was. It was S. No. Oh, you know what? We have to add one more step before this will do it. Print current guess. Print current new guess. There should be something there. Let's see what other 5 little words. I had pizza. You right guess that letter. Well, that works. Yeah, so it's not printing off. It's not doing. Oh, I know why. Because originally we were. No, that's fine. Print new current guess. Following letters. So far, the word is. Guess correctly. Try to guess the main word. I don't know. I don't know why that's not. Maybe it is printing off. Maybe I'm just not seeing it. Yeah, I'm not sure what's happening here. We can just keep on going. We'll eventually make it work. Okay. So for a letter in range, we do the check if guess in word, letter. Okay. And if guess in word, let me be a little bigger so you can see. Okay. If a letter in range, length of word, if guess is equal to letter word. Okay, good. All right, so let's go on to the next one. It's just going to be, we're going to break out of this if else statement. We'll get out of at the end of the for loop, and tabs here will matter. Current guess equals new current guess. So we want this one here, the current guess equals new current guess, to make sure it's 2 bars in. So it's technically inside this for loop. We want that to be inside of that. Actually, we want it to have it afterwards. No, I lied. We want to have it afterwards because once the changes are made to the current guess, we're going to reassign current guess to be the new version. And the newer version has the mixture of dashes and letters inside of it. Okay. All right. This was all, if you remember, part of an if statement. If guess is in the word, right? So if the person guesses, or we can actually minimize this to show you. Okay, this is all part of if guess is in the word. And what we now have to do is basically assign what happens as a result if they guess wrong, right? So we'll do else, and we'll do a print statement. Sorry, that was incorrect. And let's increase the number of incorrect by 1. So we can do wrong guesses plus equal 1. All right. And let's see. So we should be able to minimize that and check. Okay, good. All right, so we have an if statement. We have an else statement to control what happens as a result of that being wrong. Now let's end the game. And if wrong guesses is equal to the max wrong, right? If they are the same, if they've guessed the maximum number of guesses, which is the entire length of the word, we can do a print Hangman wrong guesses. And we can do print equals you have been hanged. And we can do print the correct word is word. That way we can tell the player that they what the word was in case they couldn't figure it out. We also could do else print you have won. All right, so if they have not lost, they've won. So we'll do else won. Okay, and so we have our program here. So you have the following letters. So far the word is this. Enter your guess. Let's enter A. Okay, all right, good. So we start to see this fill out. This actually is working now, where it's actually printing off the new version of itself. So we entered, we kind of know what the words are already, so we can just, easy to test. Let's do a P. All right, so P, I, let's see, I, is that working? Okay, good. Z, Z, all right, Z. Actually funny, they can enter more than one letter, so actually we can enter another if statement to check the length of their guess to make sure they're not guessing over the amount there. But we could say you have won. Let's do one more time to test to see if they get it wrong. So A is wrong. We start to see, oh no, A is right. Let's enter some other letters then. L, we start to see the head. M, N, oh, I guess I, whoops. We see the placement value though. That's good. That's working. T, E, W. Okay. So we see the entire thing work. They essentially have the number length of the guesses there. And that was incorrect. And we see that the person was hanged at the end. Okay. So that is the been hanged, correct word. Yeah, there you go. All right. So we see the entire thing work where it starts to build the characters and the number of guesses that they have is going to be limited to the amount of letters that they have available, right? That's the max number of guesses there. Actually, no, I'm wrong on that. The number of maximum of guesses is limited to the number of different ASCII little Hangman characters we have here, right? So we have 1, 2, 3, 4, 5, 6, 7. Yeah, so 7 max wrong is the length of that minus 1. So essentially, they have 6 guesses that they could possibly make, excluding this first one up here. So if you wanted to have them give more guesses, there's no way to unless you added in, additional states, additional maybe characters or things that you can add on to this that would make it longer. So if you guess a long word like Washington, they're going to get the same number of guesses as if they had to guess bear, which is sometimes easier, sometimes harder. But hey, that's how Hangman works. So that's it. Hope you enjoyed, and I will see you in the next one.